Hi, I am Sanjay Patel. In this video, we are going to introduce the concept of series and discuss what is the meaning of convergence and divergence of series. So let us start with the definition of series. We consider AN, let AN be a sequence of real numbers. Okay. Then the infinite sum of all terms, a1 plus a2 and so on. This way, the infinite sum a1 plus a2 plus a3 and so on, which we can denote by using this notation sigma n is equal to 1 to infinity an. This sum is called a series. We can also call it infinite series or infinite series associated with the given sequence. Okay, so this is the meaning of series. For example, suppose we consider the sequence an is equal to 1 upon 2 raised to n minus 1. You know what are the terms of this sequence? We can write it as, say, 1 upon 2 raised to 1 minus 1. The first term is 1 upon 2 raised to 0, that is 1. The second term is 1 upon 2. Third term is 1 upon 2 square. Then 1 upon 2 cube and so on. So this is our a1, a2 and so on. Let me write. This is a1, a2, a3, a4 and so on. And the sum of all this, which is given by sigma an, n is equal to 1 to infinity, that is sigma 1 upon 2 raised to n minus 1, n is equal to 1 to infinity. This is called a series or infinite series associated with this sequence. This we can also write in this form: 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube and so on up to infinite terms. And now our question is whether we can add all the terms and get some finite real number, or does this sum exist or not. So how to check whether this sum is possible or not? If this sum is possible, first of all, if this sum exists, then this series is said to be convergent, and otherwise, if it does not exist, we call it divergent series. So to discuss convergence and divergence mathematically, we define another sequence which is associated with the sequence an to discuss the infinite sum is possible or not. So let us define what is called convergence of series. So another very, very important definition is definition of convergent series. Definition of convergent series. Let an, or let us consider sigma an, n is equal to 1 to infinity, be a given series of real numbers. Given series of real numbers. Now we put S1, we define S1 is equal to A1. We define S2 is equal to a1 plus a2. So what I'm doing is I'm defining another sequence with the help of this with the help of this sequence an. So the third term will be a1 plus a2 plus a3 and so on. We can write the nth term of this sequence as a1 plus a2 plus a3 up to n. So we are not adding fully all the terms of this series. We are adding only some few terms. So it is also called partial sum. This is also known as partial sum of the given series. And using this partial sum, we form a new sequence s1, s2, s3. So as a result, we have the sequence Sn of partial sums of the given series Now, if we intuitively think that if I choose n very, very large, say if n goes to infinity, that means I have to write a1 plus a2 plus a3 up to all infinite terms. If that Sn as n tends to infinity, if it exists, that means this sum exists for all a1 plus a2 plus a3 up to infinite terms. So in that case, I can say this series sum is possible, and therefore the series will called a convergent series. So mathematically, we define this way: if limit n tends to infinity, Sn is equal to say S exists, okay, then the series sigma an n equal to 1 to infinity is said to be a convergent series. So this is our intuitive definition or intuition that one can define mathematically the meaning of convergent series. In this case, the value of the limit, that is S is called the sum or the infinite sum of the series. Infinite sum of this series. And we write this as sigma n is equal to 1 to infinity an is equal to S. So this S is called sum of the series. But if this limit does not exist, then the series sigma n is said to be a divergent series. So if a series is not convergent, it is called divergent. So let me write here, if sigma n is not convergent, if sigma n 1 to infinity an is not convergent, then it is called divergent series. It is called divergent series. Okay. Here, another important thing we should note is about this symbol sigma n equal to 1 to infinity an. This symbol we use in two ways. So just note that the symbol sigma n is equal to 1 to infinity. This symbol is used for series, for writing the series, as well as also for the sum. So it is clear from the context that how we are using this symbol. So it is used in two ways. Secondly, we can also have series in this form, say a0. If we start with the first subscript as 0, we can write a0 plus a1 plus a2 and so on. So in this case, we'll denote the series by the notation n is equal to 0 to infinity an. And for both the notations, We can also use a compact symbol for the series like this. In short, we can use this notation sigma an, simply sigma an only for both the things, like sigma n is equal to 1 to infinity an, or we can also use it for sigma n is equal to 0 to infinity. So this symbol we use for a series, whether it is starting with the subscript 1 or subscript 0. Okay, now let us recall the first series which we have considered, that is this one, sigma 1 upon 2 raised to n minus 1, and check whether this series is convergent or not. Okay, so let us discuss the convergence of that series. Okay, so one simple example, say discuss convergence of the series sigma 1 upon 2 raised to n minus 1. 1 upon 2 raised to n minus 1. So here we have what we can write is sigma an, the given series, is equal to sigma 1 upon 2 raised to n minus 1, which is actually in this case we have written as n is equal to 1 to infinity 1 upon 2 raised to n minus 1. And if you write in that expanded form, it is 1 plus 1 by 2 plus 1 by 2 square, 1 by 2 cube, and so on. We want to check whether this series is convergent or not. So what is Sn here? In this case, Sn, so we have Sn is equal to a1 plus a2 plus a3 up to an. That means the sum of the first n terms of this series. So this is your a1 and a2 up to the nth term, that is somewhere here, which is 1 upon 2 raised to n minus 1. This will be your an, and this will go on and on. So I can write this as 1 plus 1 by 2 plus 1 by 2 square up to 1 upon 2 raised to n minus 1. And you can immediately understand that this is nothing but the sum of the first n terms of a geometric sequence. We have already studied in our previous videos that what is the formula for finding the sum of the first n terms, say a plus ar square up to a into r raised to n minus 1. This sum is given by a into 1 minus r raised to n upon 1 minus r if r is not equal to 1, where r is the common ratio and a is the first term of this geometric series. Okay, so from the first n terms of the geometric sequence. So here you can observe that 1 by 2 upon 1 is 1 by 2, 1 by 2 square by 1 by 2 is 1 by 2. This is also geometric sequence if you consider each term separately. Then the first term a is 1, this is a, and the common ratio is 1 by 2. So I can write the sum of this n terms as 1 into, using this formula, 1 into 1 minus 1 by 2 raised to n upon 1 minus 1 by 2, because it is geometric series with a is equal to 1 and r is equal to 1 by 2. Okay, simplifying this, we get this is equal to 1 minus 1 by 2 is 1 by 2, and that I can write as 2 times 1 minus 1 by 2 raised to n. So this is our Sn. Now it is easy to find limit of this new sequence where Sn is the sequence of partial sums of the given series. And according to our definition, if limit of Sn exists, then this series sigma n is said to be convergent. So let us find whether this limit exists or not. Limit n tends to infinity Sn means limit n tends to infinity of this sequence 1 minus 1 by 2 raised to n, 1 upon 2 raised to n. Okay, and we know very well that limit of this 1 by 2 raised to n is 0 as n tends to infinity, because we have a formula for limit of this geometric sequence. So I can write directly using that formula, because limit n tends to infinity r raised to n is equal to 0. I'm using this formula, and we know that this formula is valid for only mod r less than 1. That is, the value of r is between minus 1 and 1. And here r is equal to 1 by 2. So we can use this formula and write the limit of this as n tends to infinity is equal to 0. So what we are left with is it is equal to 2. So limit n tends to infinity Sn exists and it is equal to 2. So this implies I can say limit n tends to infinity Sn is equal to 2. It exists. This limit exists. And therefore, the given series, which is sigma 1 upon 2 raised to n minus 1, is a convergent series. And not only that, we can also write that its sum, this infinite sum, is the value of this limit, that is sigma 1 upon 2 raised to n minus 1. N is equal to 1 to infinity. This sum is nothing but the value of this limit, which is 2 here. Okay. So this is the very simple example of a series, and this series is also known as a geometric series. We can generalize this example and prove as a result, the first result of this chapter, the theorem number 1, which is very useful and the simplest of all. Consider the geometric series sigma a into r raised to n minus 1, n is equal to 1 to infinity. That is a plus ar plus ar square plus a into r square plus a into r cube and so on. So this is a geometric series. Prove that sigma a into r raised to n minus 1, 1 to infinity, is convergent if the common ratio, that is r, its absolute value is less than 1. Okay, and sigma n equal to 1 to infinity a into r raised to n minus 1, the sum of this series is nothing but a upon 1 minus r. Okay, the proof goes on the same line as that first example we have considered. So let me just prove this. Say here the given series is sigma a into r raised to n minus 1, 1 to infinity, which is a plus ar plus a into r square and so on. So this is my first term, second term and so on. Let me name it. This is our a1, this is a2, the third term is this and so on. Okay. So therefore, the nth term of the sequence of partial sums is given by Sn is equal to a1 plus a2 plus a3 up to an. Now what is a1, a2, a3 and an? As we have discussed, a1 is a, a2 is the second term, that is a into r, third term is a into r square, fourth term is a into r cube and so on. So nth term is a into r raised to n minus 1. A into r raised to n minus 1. And this is nothing but some of the first n terms of a geometric sequence with a common ratio r. We can see if you divide ar by a, you will get r. Ar square by ar is also r. So it is a geometric series. And this is equal to, by that formula of finding some of the first n terms, we can write this as a into 1 minus r raised to n upon 1 minus r if r is not equal to 1. And here we have r is not equal to 1 because we are given that mod r is less than 1. That is, r is between minus 1 and plus 1. That is, minus 1 less than r less than plus 1. Okay. So therefore, if you take the limit of Sn as n tends to infinity, limit of Sn as n tends to infinity, you will get limit n tends to infinity of this term, that is a into 1 minus r raised to n upon 1 minus r. And according to the formula known for limit of geometric sequence whose ratio is less than 1, we can write directly the value of this limit as 1 minus 0. This tends to 0 as n tends to infinity because mod of r is less than 1 upon 1 minus r. Because it is a geometric sequence with r is less than 1. So we know the formula that limit n tends to infinity, r raised to n is equal to 0. Whenever mod of r is less than 1, let me write this. Whenever mod of r is less than 1, this limit is 0. And here we are given that mod r is less than 1 in the hypothesis. So this gives us a upon 1 minus r, where a is the first term and r is a common ratio which is different from 1. So this number is some finite real number. So it is well defined. So this is some finite real number. And that means the limit of Sn exists. And therefore the conclusion is the series sigma an, that is sigma a into r raised to n minus 1 is convergent. This is a convergent series. Okay, but the condition is if the ratio r satisfies this rule, that is minus 1 less than r less than plus 1, that is the number r belongs to open interval minus 1 to plus 1. And also in this case, we can write that the sum of this series sigma a into r raised to n minus 1 for n is equal to 1 to infinity as a upon 1 minus r, which is the limit of Sn. The limit of Sn is called the infinite sum of the given series. So the theorem is proved. Hence the theorem is proved. Hence the theorem is proved. So as far as the geometric series is concerned, it is very simple, and we can discuss using this theorem whether the geometric series is convergent or not. And if it is convergent, we can write down its sum using the formula a upon 1 minus r, provided mod of r is less than 1. So this is very important condition here for using this theorem. If mod of r is not less than 1, that is if mod of r is greater than or equal to 1, then this series is divergent. Let us write down this as a remark at the end of this theorem. So let me write this way. If mod of r is greater than or equal to 1, then the series, the geometric series sigma a into r raised to n minus 1, n is equal to 1 to infinity, is divergent. The proof is again simple. Let us just write the main step, because if you find the limit in this case of the sequence of partial sum, that is limit n tends to infinity Sn, then you will get limit n tends to infinity, that Sn is same what we have already obtained in this step, that is a into 1 minus r raised to n. This is your Sn. It remains the same. Only the value of r is changed, a into 1 minus r raised to n upon 1 minus r. And remember that here this this a and 1 minus r is constant. So I can write it this way, limit n tends to infinity, a upon 1 minus r, this is some finite real number, into 1 minus r raised to n. But as the value of r satisfies this condition, this limit n tends to infinity of r raised to n does not exist. This tends to plus or minus infinity. So this tends to infinity, or I can say this limit does not exist if the value of r is not between open or not in the open interval -1 to +1. Okay, so therefore I can say the series sigma a into r raised to n minus 1 is divergent when mod r is greater than or equal to 1. So in the next lecture we are going to discuss some more examples of convergent and divergent series and how to find the infinite sum of the convergent series. So thank you.